This unit, I spent a little bit more time on this unit than some of the other units because it has a very huge impact on what's happening in grade 12. We spent probably a third of the course of grade 12 is based on this starting point with this unit. Now, we're going to study angles. We're going to study them slightly different than what we have studied them before. There's two things that are going to happen. Number one is we're going to look at angles based on the quadrantals, which is basically just your grid axes. And we're going to study them based on two very significant triangles in which we are attempting to solve for angles without the use of the calculator. So it begins here. We don't do it as much without the calculator in this course, but there are a number of angles that are pretty significant. Now, an angle theta is in standard position when the vertex of the angle is located at the origin on a Cartesian plane, and the initial arm of the angle lies along the positive x-axis. So starting with this x-axis right here, that's called your initial arm. You work in counterclockwise direction to have a positive angle. So an angle such as this, that gives me an angle of theta here. Okay? So that angle would be slightly greater than 90, right? But less than 180 because it's in the second quadrant. So we're now going to label the quadrants. And we're going to put in here that the angles in this quadrant are between 0 and 90. The angles in this quadrant are between 90 and 180 degrees. Down here would be between 180 degrees and 270. And then 270 less than theta less than 360. Okay? All right, so the angles can go anywhere in one of these four quadrants. If they are going in counterclockwise direction, that's a positive angle. If it goes in the clockwise direction, if I work back this way and around, the angles will be the same, but they're in a negative direction. All right? Now, all angles, I'm raspy here today. All angles found in this first quadrant are referred to as the reference angle. Now that's extremely important for us, so we want to make a note of that, the reference angle. The reference angle is the angle that allows us to find ratios in the other three quadrants that are similar or exactly the same as the one found in that quadrant there. Okay? Any questions about this so far? There's not much to it yet.
So the reference angle is the first quadrant?
It's an angle found in the first quadrant. Okay? It'll make more sense as we go through. But for right now, I just need you, just that for right now, and then I'll explain the reference angle and how it works. Okay, now, if there's no other questions about that, we have two extremely important triangles that we need to know, and one of which will be slightly different than what the book looks like. And I'll explain that in a second. The first one is a 30, 60, 90 triangle. Now, this is the most important triangle that you're going to know in your high school days. The reason being is it's the basis for setting up all of the ratios throughout that 360-degree Cartesian plane that are with 30, 60, and 90 as your angles. Now, first thing I want you to do, punch into your calculator the sine of 30 degrees. Okay, that number right there is the number that you absolutely have to remember from here on in. The sine of 30 degrees is 1/2. That becomes important because when I label this, 1/2, all right? Then that means then, if I use my Pythagoras' theorem, square root of 4 squared subtract 1 squared is square root 3. Okay? What we are going to be able to do as we go through this, we are going to write the ratios for the sine of 30, the cos of 30, and the tan of 30, as well as the sine of 30, the sine of 60, cos 60, tan 60. The sine of 30, the ratio is 1/2. The cos of 30, the ratio is root 3/2. And the tan of 30, the ratio is 1/√3. Okay? Now these are important because we are going to do our best to work away from using calculators and finding ratios of angles. That's our end game when it comes to doing this. All right, so the sine of 60 degrees, what's the ratio of the sine 60? What's the side opposite 60?
Root 3/2.
Yes. Root 3/2. What's the cos of 60 degrees?
1/2.
And the tan of 60? Root 3/1. All right? So as long as you can remember the sine of 30 is 1/2, you redraw this triangle out so then you can get all of the other angles. Now, what you don't know yet, what you sort of do from applied, is you'll remember that the sine of an angle, so let's say the sine of 30, has the exact same ratio as the supplementary angle to 30. So the sine of 150 has the same ratio. So what's the sine of 150? 1/2. Okay? The cos of 150, root 3/2. These are just our very early on, those are the angles that we want to make sure that we remember. Okay? This last one, I'm going to do similar to what the book does, but then I'm going to change it. If these are 45s, they have the same length. So I'm going to make that length 1. So I've got 1 and 1, which then makes this length over here. So that's 1 squared plus 1 squared, which is 2. That would make this square root 2 here. Don't write this down. Don't write this one down. I'm going to switch it for you, okay? So therefore, if I'm looking at the sine of 45, cos of 45, and tan of 45, the sine and cos of 45 are going to be 1/√2. Would be that, right? Now what you learned in grade 10 is that we don't like to have square roots on the bottom of fractions. So we rationalize it by timesing the top and the bottom by root 2/√2. So the long and short of it means this. Oh, big one. What I'm going to do instead is this. Make that root 2, make that root 2, and that 2. That's going to give me the same thing. Okay? Because if I times this by root 2/√2, what do I get? Root 2 times 1, root 2 times root 2 is 2. Okay? So the sine of 45 degrees, the ratio is root 2/2. Cos of 45 degrees, the ratio is root 2/2. What is the tan of 45 degrees? 1. Yes, well done. Tan of 45 degrees is 1. Now, if you punched all of these into your calculator, you would get those solutions for all of them. If you knew what root 2/2 was as a decimal, and you punched in tan 45, you get the same value. Okay? So these are the two primary triangles that we are going to focus on from here to the end of, into grade 12. All right? There's no other triangles that we worry about, just the 30, 60, 90 and the 45, 45, 90 triangle. Okay? All right? We're going to get a lot more into this. Any questions or concerns about this guy so far? It's not hard, but again, you have to remember sine 30 is equal to a half. And then everything else sets up from there for this triangle. Okay? All right. Let me just see where they're going so that I can... All right. Okay, I'm just going to follow through the book. I like how they pace this, how they go through it. Okay, so take a look at we're going to write this out in our book. Sketch each angle in standard position, so 80 degrees. It says for theta equals 80 degrees, the angle lies between 0 and 90 degrees. So let's write that in our book. Right?
This is 2.2.
No. Example 1 of 2.1. Okay? So how do I draw 80 degrees? Just like this. There it is. That's it in standard position. 120 degrees. Which quadrant is 120 degrees in? Second quadrant. Right? So that would be right here. That makes 120 degrees right there. Sketch that. 266 degrees. Where does it lie? Which quadrant? Third quadrant. And it would be somewhere down here, in which I have that right there. Okay? So far, so good?
That's 266 degrees.
That's right. Yeah. Okay? Nothing too difficult about that one, is it? Any questions?
It asks us where the terminal arm lies. So which
That's the
quadrant?
blue one.
That'd be the third one? Third quadrant.
Oh, I see, yeah. Third quadrant. Okay. You label your quadrants 1, 2, 3, 4.
Oh, okay, so you say, so you write down the last one it's in?
Yeah.
Okay.
Okay? Anybody else? We're okay? All right, now I'm going to go back to this reference angle thing. The reference angle, let's see. Now I said that the reference angle is always made in that first quadrant between 0 and 90. But the reference angle is also, in the other quadrants as well, always made with the x-axis. Okay? So, I'm going to start by showing you, this is not in your book, I'm going to start by showing you the simple way of looking at this. Okay? I have four angles that all have the same reference angle. So, don't write this out, you don't have to. My reference angle, so I denote it by theta r. I'm going to say it's 30 degrees. So I want another angle in quadrant 2 that has the same measure as my reference angle. So I go like this. Right there, my reference angle is 30 degrees. So what angle is that then?
150?
150 degrees. That's right. So 150 degrees has the same reference angle as 30 degrees. Okay? What about the third quadrant? What about down here? This is 30 degrees here. What is the measure of that reference angle? Or sorry, what's the measure of that angle that has the same reference angle as 30 degrees? 210. 210. Okay? And then what about down here? Reference angle, 30 degrees. What is it? 330 degrees. 30 degrees, 150 degrees, 210 degrees, and 330 degrees all have the same reference angle. That reference angle being 30 degrees. Okay? So when they ask you for the reference angle, you are always finding the angle that's made with the x-axis. All right? So when we get going through this, all right, my reference angle is found in this quadrant here. Okay, to find out what that angle was, I go 180 degrees minus the reference angle. Right? That's how I got 150 degrees. Down here I went 180 degrees plus the reference angle. That's how I got 210 degrees. And then over here, okay, that's 360 degrees minus the reference angle. And that's how I ended up with 330 degrees. Okay? That never changes. If you want to find an angle that has the same value, okay, as the reference angle, this is how you get it. You take 180, you subtract your reference. You take 180, add your reference angle. 360, subtract your reference angle. Now, again, I'm going to go a little more into this than I need to, so that when I come back to it in a week's time or a year's time, it's going to make a little more sense to you. Okay? We're going to talk about coordinates. All right? Now, you know what? I'm going to leave that for a second. Just give me my bad. I'll come back to it in the next section. Okay? So for right now, what I need you to know is that the reference angle is always less than 90 degrees and always made with the x-axis. No matter what quadrant you're in, the reference angle is always made with the x-axis. Never, ever, ever with the y-axis. Just the x. Okay? All right? Okay, so let's look at page 58 then. Determine the reference angle for each angle, sketch it in standard position, and label the reference angle. All right, so I have an angle of 315 degrees. Which quadrant is 315 degrees in? Fourth quadrant, right here. Right? So there's 315 degrees. What is my reference angle then? The terminal arm is in quadrant what? 4. So subtract theta from 360 to get your reference angle. Therefore, your reference angle is, as Cameron said, 45 degrees. Okay? We all right? (201 degrees). What quadrant is 201 degrees in? Third. That's right. So that's down there. That guy's 201 degrees. What is my reference angle here? What is it? 41 degrees. Okay, 201 degrees. Now, I'm putting a bunch of information on the board, but let's just take a second and let's put some thought into this. All right? If I'm talking about just looking at the Cartesian plane, just the grid, right? What is the angle from here to here? What is it? It's 90 degrees, right? And then the angle from here to here is 180 degrees. And then if I went all the way down to here, what is it? 270 degrees. So without knowing anything, I can probably determine which quadrant these things go in just by knowing that 90 degrees makes a right angle, 180 makes a straight line, and 270 would make a right angle down in the bottom. And then I could just draw them out that way. Okay? So I don't have to, remember all that other stuff. I just need to remember, hey, I know what 90 degrees looks like. I know what 180 degrees looks like. Okay? Working example 3, determine the angle in standard position. Determine the measure of all angles in standard position between 0 and 360 degrees that have a reference angle of 35. Okay, so let's draw our reference angle. Since we just basically did this, right? I used 30, they're using 35 degrees. Okay.
You can use any number, right?
So, what does this measure then? How do I find it? Somebody put up your hand and tell me. Aaron, go ahead.
180 into 35.
180 subtract 35. What's 180 subtract 35? 145. All right. Brooke, down here.
180 plus your 35.
Exactly. So that gives me 215. Okay. And then down here, how do I get it? Morgan?
Subtract it, right?
From what?
Your,
Oh.
It would be from like 360.
Atta girl. Good for
So
you.
it would be 355 or 20 almost.
Good job. You got it right. You did the right thing. This one is 360 degrees minus your reference angle. Okay? Not that complicated, right? Are we okay with this so far? All right. I'm going to leave work example 4 for a second. I want to go through that second section now. Okay. Now, this guy sets us up. I'm going to explain to you what it looks like in grade 12. And then I'm going to go back to the very basics. So I'm going to do this real fast, okay? Don't copy this down. All right. So what happens in grade 12 is this. I'm going to give you ratios. I'm going to give you angles. And you need to tell me what the exact values of those are based on what we're going to learn. So the first thing that we know is that we're going to call this the unit circle. The reason we call it the unit circle is the radius is 1 unit. So now I want to find all the coordinates around this unit circle. That one would be 1 and 0. Okay? This is also 0 degrees. Right? Okay? This guy up here is 90 degrees, right? Well, what's the coordinates at 90 degrees? 0 and 1. Over here is 180 degrees. The coordinates are -1 and 0. And then 270 degrees. The coordinates are 0, -1. 0, -1. Now here's something really neat about this. All right? This x value represents the cos ratio. So if you took the cos of 0 degrees on your calculator, you get an answer of 1. The y value then is the sine ratio. So the sine of 0 degrees is 0. Okay, so far? All right? So all those x values around that circle represent the cos of the angle, the ratio. All the y values around that circle represent the sine of the angle, the ratio. Okay, so I'm going to look quickly at 30 degrees. All right? 30 degrees, so I'm going to go like this. I'm going to say, okay, well, this is 30 degrees, and I want the ratio for 30 degrees. Well, what did we say the sine of 30 degrees was? 1/2. That's the ratio. What's the cos of 30 degrees?
Can we punch in our calculators?
Nope.
Oh, you wrote that down.
It's off that other triangle.
Is the thing at over 3?
Square root?
Square root of 3 over 2?
Yes.
Or radical?
Square root 3 over 2. There's my ratio. Okay, and then we go to, the next thing you have to do is go to 45 degrees. Well, what are the ratios there? What's the sine of 45 degrees? What is it?
Square root 2 over 2.
Square root 2 over 2. What's the cos? Square root 2 over 2. That's the ratios. Okay? Then I go up here and I do 60 degrees. And the ratio for 60 degrees, what's the sine of 60? Root 3 over 2. What's the cos? 60? 1/2. All I do is switch those two. So now I got to go all the way around this circle doing the same thing. Now I'm just going to show you the 121, just because, and then I'm going to stop for today. 120 degrees. 120 degrees. What's the reference angle here for 120 degrees?
60.
It's 60 degrees. So then the coordinate for this guy is going to be the same as the reference angle in the first quadrant, which was 60. What do you think is the only change I have to make?
A negative.
A negative.
For both of them? No.
Is
Yeah.
y positive or negative up here? It's positive. So is x positive or negative in this quadrant?
Negative.
Negative. So I only have to switch that one. So it's the same coordinate, minus 1/2, root 3 over 2. And then I go all the way around the circle. That's what we're getting to in grade 12. And then we use those values all the way through. So I could then find the sine of 15 degrees using what I know here, the exact value. I don't use the calculator anymore to find trigonometric ratios. All right? This is where we're going to. This is grade 12. This is a 30-year course in grade 12, is working with this, what we call the unit circle. All right? We'll start it in grade 11. We'll go through all of this. We only add one thing to it in grade 12, and that is we change that to radian measure, which we'll talk about. But it's very easy. But this is where we're going, okay?
That's
So-
pre-calc, right?
Yeah.
Okay.
There's a little bit of that. We use that. We still use that in grade 11 or grade 12 applied as well to circle, because that's how we get our sine graph, is from that circle. But anyways, that's neither here nor there. Now, when I look at this again, I want to show you one more thing. Okay? This you can probably copy down. So I'm going to take this coordinate right here. This coordinate is x, y. All right? And my radius is r. Because I said on the last slide, I said over here that x was the cos value of the angle and sine was the y value. Well, I'm going to show you why right now. Here's my angle right here, theta. Okay? What is this distance from here to here? What's the horizontal distance?
Sit over R.
No. It's simpler than that.
1?
No, the distance isn't 1. My radius is r for now. If this coordinate is x and y right here, I'm going x this way and y that way, right? So what's my horizontal distance then?
Y.
X. And my vertical distance?
Y. Sorry.
Those two things
right? So I've got that so far. You agree? All right. What's the cos of theta then? Using this triangle, what is the cos of theta equal to? What's the side adjacent to the angle?
X over R.
X over R. Like that. What's the sine of theta then?
Y over R.
Y over R. And what's the tan of theta?
Y. X. Y over X.
Y over X. Okay? Those are just simple ratios. Simple ratios. Now, remember what I said on that last circle? What did I say the radius was on that last circle?
1.
It was 1. So the cos of theta is x over 1. What does the cos of theta equal? Equals your x value. The sine theta is y over 1. That's why it equals to your sine theta here. So that's why that is why I showed you that. Okay? All right? And r you can find using x squared plus y squared. Now, let me go back to this, sorry. Now that I know that the cos is your x value and the sine is your y value, that helps me set up around the quadrant when they're positive and when they're negative. All right? So right here, your x and y are both positive. That means that cos theta, sine theta are both positive ratios here. All right? Over here in this quadrant, cos theta is going to be negative. Down here, they're both negative. And over here, just the sign is negative because y is negative there, right? Now, I'm going to give you a simple way to remember this, okay? Cast. Pretty straightforward, right? As long as you know where to start the C. What's positive in this quadrant? Cos.
Cos.
This one?
Oh.
All. Sine. Tan. Why is tan positive? Because you're going a negative over a negative. That gives you a positive. It's called cast. Okay? Now again, I'm giving you a lot of information here. Because I've got kids, like people away next week, right?
Oh, yeah.
So I know it's a lot. So Monday, Tuesday, Wednesday, we'll just be kind of catching up, finishing 1 and 2 off. All right, so I'm going to show you an example question of what happens here. Now this is one, for whatever reason, when we get to grade 12, we forget this. So I make a note of it. I'm going to graph the following. The coordinate 12 and negative 9. And it wants me to set up the ratio. I want the sine ratio, the cos ratio, and the tan ratio for this. So here's what I do. -12, -9 is somewhere down here, right? Okay? And I'm going to make that theta. Remember, my theta is always with the x-axis. So this is 12. This is -9. First thing I want to do is find out what my radius is here. Okay? So 12 squared is 144. -9 squared is 81. That makes 2 1/4. The square root of 2 1/4 is 15. Okay? A squared plus B squared equals C squared. What is the sine of theta in this question?
Nine over 15.
Done. That's it. You're absolutely right. What's the cos of theta in this question?
12 over 15.
And what's the tan of theta?
-9.
And I'm done. That's all it wants you to do. Find the trig ratios from that. Okay?
We don't have to solve those, we just have to do the ratios.
Just the ratios is all I'm looking for. Okay? Questions? Any problem?
No, she cleared up the question I had.
Okay. Does anybody else have a question? So we've done this since grade 9. We've done right angle trigs since grade 9. Right? Sine, cos, and tan. The only difference now is that we're using this Cartesian plane to do it. Okay? All right. Let's look at this next one. Determine the exact values of the sine, cos, and tangent ratios for theta equaling 120 degrees. So I just talked about this. Up here,
Yes.
120 degrees. What does that make my reference angle? 60 degrees. Okay. So what I've learned then, from what we have done already, is I know what this coordinate is. What is that coordinate?
Oh, that's,
What's the cos of 60 degrees?
1/2.
It's a half,
Yeah, 1/2.
right? But it's in the second quadrant, so what do we know? Which one has to be negative? X or Y? Oh, so I've got negative a half and root 3 over 2. So now, sine of 120 degrees is? What's the sine of 120?
1/2.
Sine?
Oh, not.
Y value. What's your Y value? Root 3 over 2. What's the cos of 120?
-1/2.
Negative 1 over 2. And the tan of 120? Yeah. Or sine over cos. So you could take root 3, so the tan of 120, if you don't remember what it is, you could take root 3 over 2 divided by negative a half. So that's root 3 over 2 times negative 2 over 1. Those cancel. The answer is negative root 3. Negative root 3. That's your tan value. All right? I have 2 minutes, I figure. Questions? So again, it's based on your reference angle. Your reference angle is always, right now, is always going to be 30, 60, or 45. That's it. Those are the only 2 triangles that we're going to use. Okay? Last one, most important one. This is the guy that we have to be really on top of. We do need our calculator for this. So, they say that the ratio is tan theta is negative 0.9004. Okay. So I want to find all of the values between 0 and 360 that give me a tan ratio of negative 9.004. Sorry, 0.9004. So here's what you're going to do first. Find out what the reference angle is. So I want that angle in the first quadrant. Anybody know how to find that out?
Take the second function tan.
Yes, but don't do the negative.
Right. 42 degrees or 41.999.
We'll go with 42. So that's what I have right there, 42 degrees. Using my calculator. All right? Now, what you need to do now is which two quadrants is the tan ratio negative in? What two quadrants is tan negative?
2 and 4.
2 and 4. Because what are the only two quadrants it's positive in?
1 and 3.
1 and 3. So it's got to be negative in the other ones, right? I mean, you don't follow that?
But T stands for tan.
Right. So it's positive in this quadrant, and it's positive in that quadrant. So it's negative in the other two. Okay? So my reference angle is 42 degrees. In the second quadrant, this is how I write it. Theta with the 2 to show that second quadrant. What is that angle right there? How do I find it? 180 take away 42. What is that angle? 138 degrees.
And that's with the same reference angle, right?
Yeah. All right, tan's negative in this quadrant. So in quadrant 4, what is that angle? What do you think it is?
318.
318 degrees. On your calculator right now, punch in tan 138. Tan 138. What do you get?
Negative 0.9.
Okay, punch in tan 318 degrees. Same thing.
Oh, it's because of this.
It's because of this circle on this Cartesian plane. All right. Now, how does this make sense? How does this go back to what you have done? Think about ambiguous triangles in applied. To get that second triangle's angle, you had to take 180 degrees, subtract that angle to get the supplementary angle. Because the sine of 30 and the sine of 150 was exactly the same. Well, the other ones, cos and tan, also have two angles between 0 and 60, 360 that give you the same angle. And we do this every time. Okay? All right, that's it for today. We will Tuesday and Wednesday we'll work on 2-1 and 2-2. So that doesn't put anybody else behind. So if you're not here, Tuesday and Wednesday you work on it.
Also, are you going to take this with you?